Hi, I'm Francesco Poi and this is Just for Funk. So, welcome to episode number 30 of Just for Funk. Today we're going to try to answer a question that I've received from actually 3 or 4 different people, which was basically, hey, what is gRPC? I want to learn more about it. Tell us more about it. So gRPC, there's a lot to learn, but the most important thing to know is that gRPC actually sits on top of another technology called protobufs. And rather than going directly into gRPC and trying to understand all of the things together, I decided that we're going to do an episode on the basics of protobufs. What do they are? What are they? That's better English. So what are they? How do you use them with Go? And then basically, what are the limitations and where does it start to make sense to have things that are higher abstractions, such as gRPC? Does that sound fun? Let's get started. Today we're going to be building something quite similar to a database. A database with a specific goal, which is just to store tasks to be done, and that's pretty much it. You'll be able to add a new one and then list it. Maybe later I'll add more and I'll add so you can delete them or modify them, etc. My idea is to start with something quite simple, just using protobufs and Go. Then from there move into a bunch of different topics like gRPC, but also we can talk about things like version control of those messages once they're stored. What do you do if that schema changes? Also, I want to talk about how to create CLI tools. So I might end up talking soon about Cobra. If you're interested, please leave a message letting me know that you're interested in that, so I'll work on that. Anyway, so how do we start with this? Well, protobufs is just a format to store messages. Something similar to JSON or XML or any other format you might have seen before. TOML, YAML, and all the mals. What does it look like? Well, there's 2 different things. One is the schema, and the other thing is the values. So basically you have a file describing what the values look like, and then the values are the actual instances of that given type. So it's kind of like when you say in a programming language, you have types and you have values. Here it's pretty much the same. You have message types, and then you have values of those message types. Anyway, let's start by creating a new directory. I'm going to call it to-do because we're going to be doing to-do list, to-do tasks, whatever you want to call it. And I'm going to define a to-do.proto. And proto, normally this is the extension of the protobufs files, which are the definition files that give you the schema. You're going to start by saying this is syntax proto3. And why proto3? Well, because there's been pro1 and pro2 before. And proto3 is actually the simplest one. It's the one with the least amount of features, which is something quite interesting. Proto2 does a lot of really fancy things. Proto3 is down to earth, really simple, but also very simple to use. So once I have this, I'm going to be able to define a message. Actually, before that, I'm going to say that this is the package to-do. So package to-do. And then we're going to define a message, which is the equivalent basically of a type. So I'm going to say that the message, let's call it task, has some text string and done boolean. I don't know if it's boolean or bool. We'll see soon. Anyway. So here what I've done is I've created this message task that has 2 fields, text and done inside. The text is a string, done is a boolean, and then you have 1 and 2 there. Those are actually the interesting parts because no matter what you do later on, like you may want to change the name of the field text to something else or name it done, or you may want to add an extra field in here. Let's say that you want to add, I don't know, it's a task description, let's call it. You can add it in the middle as long as you add a number that you've never used before. So those labels actually allow you to later on move from version to version. But for now, let's just keep it simple, have only 2 of them. And now that you have this, right, you have the description of a message. But how do you use this with Go? Well, the first thing you need to do is you need to install protocd, which is the proto compiler. I've already installed it. You can install it normally using brew install protobuf or apt-get install protobuf or something like that. It's already installed, so you will see that I have a protocd program. When I run it, it just tells me many things. But what I can do is go to my to-do right here and do protocd, go out here, and to-do.pro by dash go out. Text is not defined, done is not defined, because this is the other way around, because this is not go. This is protobufs. So it's a string text and a bool done. Are you happy with that? Cool. So that's how it works. The other way around. I always mix it. Anyway, this created to-do.pv.go, and this code generated directly from this tool. And this is Go code. So you can see that it's created a type that has two fields, text and done, string and bool. This is pretty nice. On top of that, there's get text, get done. There's other fields and methods that helps us figure out how to use these task messages. But let's get started and actually write some code for this. I'm going to create a very simple CLI tool. We will make it better later on, but basically it's gonna have two subcommands. I'm gonna call it to do. Let's actually do it here. Command to do and main.go in there, so that way it will actually be called to do. And for now, let's just do this. So if I do go install of command to do, whoa, not happy. Oh yeah, of course. Go install of command to do, and I do to do, and it says to do. Perfect. So we have a to do command line. Easy. We're going to do more things. So we're gonna use flag and say that if the number of arguments, let me autocomplete, if flag.in argument is less than 1, then we're going to say missing subcommand list or add. We're gonna have only those two for now. We're gonna print that to standard error. Let me remove this so you have more space to read. And OS exit 1. So let's try it again. We're gonna do go install and run it. To do complaints says misses on command list or add. To do list just says to do. Perfect. And now I'm going to do a switch on the subcommand, which is flag argument at position 0. And we're gonna do a switching command. If it's list, we're going to call list. If it's add, we're going to call add. That's gonna pass the args from 1 over a string. So I'm going to join all of these. The whole idea is that add will receive just a long string. That's the text that I want to create in the task. Those do not exist yet, so it's normal they complains. And finally, if it's anything else, default, not defer, but default, we're going to say unknown subcommand. Okay, so let's create, and finally, if the error is the nil, then we're gonna print stdr, the error, and OS exit 1. Fprintln. Okay, so what is add going to do? Add, given a text and a string, is going to return an error. And let's say that for now is gonna return nil. And list is going to return just an error. For now it's going to return nil. Let's go install, to do list, nothing, to do add, nothing, to do food, that should complain. Perfect. Okay, so this looks like a very simple, basic command line CLI tool. It could be way more complicated, but today the point is about protobuffer, not about designing nice CLIs. That's an episode that could come later. Anyway, so what do we do with the add? What do we do with list? I'm going to define a new constant. It's going to be my db path. I'm going to call it my db.pb. pb stands for protobuffer. And what we're going to do is when we want to add, we're going to open that file and then encode the message directly there, right? So we're going to first create a task value. That's going to be to-do.task. And hopefully Go imports realize that to-do.task comes from this to-do.task that is defined here in our to-do.pb.go. So it's able to find it and add it directly here. So this is complaining because we're not using it, but that's fine. Then what I'm going to do is the fields. I'm going to say that the text is the text and done is false at the beginning. And now, before we do anything else, I'm just going to print this task. So I'm going to do println task string. Is that a thing that this does? Actually, let's use proto new encoder. No, sorry. proto.marshall. You're going to see that there's this other package that is very useful. That is the wrong one, Google. How is that not the good one? So go doc proto protobuf proto. Okay, so this is the path I want. The other option is also valid. It's for a different implementation of protobuffers. It's called GoGo, and it's supposed to be faster. I've never used it personally. I'm using this one because basically the API is exactly the same. But you can go check it out. It's that GoGo instead of Golang for protobuf, and you'll find something interesting. That provides a bunch of things, and one of them is these marshals. And we can do a marshal text string and give anything that satisfies that message interface, which happens to be any of the messages created with protobuffers. And we can print this. Okay, so let's try that. If I do go install, let's do to-do add hello there. Okay, and create text hello there, and nothing for done because it's false by default, so it's normal that it doesn't appear. That's cool. Now what we want to do is we want to encode this in the file. Now we could encode this as is, right? We could encode with text, but the whole point is that we want something that is very efficiently encoded, and binary is better than text. But also we want something that will allow us to move into new versions and add new fields in a quite easy way, right? So rather than using JSON or XML, we're going to use directly protobuffers. So how do you do that? It's actually not that different. And you simply do pro.marshal of the message, and that's going to return a slice of bytes and an error. So if the error is nil, we're going to return could not encode task, and that is the error. If we're able to encode it, then we're going to write it at the end of the file. So we're going to do os.openFile. We're going to open our db path. The flag, this is where it gets interesting. So what do we want to do with the file, right? We're not going to be reading, it's going to be write only. But also, it's going to be something that we want to create the file if it didn't exist. If I'm able to remember how to write it. Create. So that will create it if it doesn't exist. And also, if it already exists, we do not want to delete all the things we had before. Instead, we want to append. And then we're going to be using 666 for the files. That will give us a file and an error if the error is not nil. If the error is not nil, then return the error could not open that file, db path, and error. Okay, otherwise what we're going to do is we're going to write the bytes into the file. So we're going to do f.write of b, and if there's an error, we should return an error, could not write task to file, and this is why. And to finish, we're going to also take the error for f.close because we're writing something, so it's important to make sure that we actually wrote it correctly. If the error is not nil, we're going to return could not close file here, db path, and error. Otherwise, we're going to simply return nil. Okay, this is not happy because there's nothing new. Okay, so this looks like it compiles. So let's try it. Go install. And now I'm going to do, so let's see, there's no files in here, but when I do add hello there, it created a mydb.pd. And what's in there? Well, if we do file of that, it will say that this ASCII text, which is interesting because I really don't think so. Let's try to open it. How is it possible that it doesn't work at all? Oh, interesting. Okay, so it's actually not ASCII. There's extra things that we cannot see. If I do cat, it looks almost normal, but if we do hex dump of that, you will see that there's extra things. We can see easily by doing -c for character. There you go. So you can see that hello there, but also there's those -nv things here. If we add, let's say one more, potato, we will be able to see potato and then some other value in there. So there's the strings we put in there, they're still there, but also there's some extra fields, and those are the ones that will allow us decoding the file easily. Okay, so let's try to do that now. Actually, before we do that, you can also do something that is quite useful if you want to see what's inside of a protobuffer. Proto-C. There you go. So we're able to see proto decode row. So we're able to get the database directly and send it to proto-C and decode it raw. This is raw because, as you can see, we're actually not given the description of the file. And so the .proto that defines what are the name of the fields. So here we cannot know what is the name of the field. We just know that it's the field with label 1. That's it, right? Which is fine, actually. So how do we do that with code? Well, it's actually quite easy too. First thing is we're going to, let's just read all of it. So I'm going to do io-util read file of db path. That will give us a bunch of bytes and an error. If the error is not nil, we're going to return an error saying could not read this file, db path, and error. Okay, otherwise, we would close it at the end. No, we don't need to close it because we didn't open it. We just did read file. That's pretty good. So what we're going to do is we're going to simply read from it. Now, the problem here, which is, how do we know when we're done reading, right? There's a bunch of files, one after the other. We have not stored anything letting us know when to stop reading. So there's a couple of ways of doing it. One of them is to basically try to find a separator and just use that. But the thing is that in order to use that separator, it needs to be something that you're sure will never appear in between the files, right? And to be honest, I do not know which character would work for that. Instead, what we're gonna do is we're going to do something that happens very often when you're doing binary encoding of fields or anything else, where you first store the size of the thing that you're going to store right after. So for instance, in this case, you'll get something like an int64 saying this 17 bytes. And then we know that the next 17 bytes correspond to one protocol buffer message. And then we'll decode that. So we're going to do that. But before, let's try to see what happens if we try to simply decode everything. So what we're going to do is create proto.unmarshal. So as you see, it gets bytes and message. The message is going to be a task. So to do the task, we're going to read from B and we're going to read into task. If that's an error, we're going to return an error saying could not read task, and this is the error. Otherwise, we'll return nil, but also you want to do this forever. So if the error equals IOEOF, else this. So, and of course, we also need to print. So we're going to print task.text. And actually, let's do it. If task.done, done. We're going to print f. Let's do it like this. Let's use emoji. Deck. V. Okay. Sure. Let's go with emoji. Yeah. So I'm gonna say that. Else printf. What emoji can we use to do? Use this one. Cool. And then we're going to print a space and task.text and end the line. Okay, so let's try to run that now. So go install to do list, and it goes there forever. That's normal. And now I cannot kill it. Okay, it died. Why is this going on? Well, because we're actually not advancing, right? What we'd like to do probably is to know how long we've read with a marshal and say, okay, so the next piece is going to be right after, right? But that's not something we have. So instead, what we're going to do is we're going to apply the technique I told you and add the length of every message right before we encode the message. So how do we do that? We're going to start here and say we're going to do gob.new encoder into file. And we're going to encode an int64 of the length of the message. And if this fails, we're going to return an error. Could not encode length of message. And so that will encode the error at the beginning, but not the error, the length. And then here we're gonna do the opposite, right? The first thing we're gonna read is we're going to read, so gob.new decoder of bytes.new reader of B until 4. Okay. So actually, let's make sure we do this correctly. So I'm going to remove, so if the length of B is 0, then return nil. Else, if the length of B is less than 4, then return, what would be the word? Missing, not remaining these bytes. What to do? Who knows? And left of B. Okay, so now what we're gonna do is we know that this should never happen. So if error is not nil, we're just going to complain. We get the 4 first bytes and we decode length. Var length is an int64 as we did up there. If the error is nil, then we're going to return an error saying that we could not decode message length, and that will do it. Otherwise, now what we're going to do is we're going to unmarshal. So I'm going to move B a little bit forward. So I'm going to do B is now from forward. And we're going to give the capacity to read up to length. And then we're going to move this again forward. Cool. So just to go real quick, basically we check every time. If we have an integer, if we're done, right? But if we have an integer of 64 bits, we check that that is the length of the next message, and then we use that to read the specific section of the message that counts for us. Then we're gonna do go install again, and when I run to do list, it doesn't work. Okay, so this doesn't work, but it's actually not completely unexpected because the message we have doesn't even follow the encoding policies that we decided. So let's do it again. So go install just in case. I'm gonna do to do add hello there, and now to do list, and it will say hello there, which is to be done. If I do to do add something else, and then to do list, we'll see that now we have two of those. Perfect. So this now works pretty well. Okay, so with this, you now have a pretty good idea of what protocol buffers are and what they are for. They were created as a platform-independent way to store data like this or to send them through the network. And one of the use cases when you're sending that through the network is to have a REST API, well, an API, REST or not, that's a different topic. But it's an API that allows you to request messages and receive messages that are typed. So it's kind of like a very well-documented API. And that's actually what gRPC is basically those API policies applied on top of protocol buffers. And maybe next episode will be about that, or maybe next episode will be about how to make this a better CLI tool with Cobra. Which one do you prefer? Let me know. So with this is the end of the episode. Thanks so much for watching. Please tell me what you think about this episode. I know that many people enjoyed the episode from last time where I was talking about more like dependency injection and more like software engineering things. Do you want me to talk more about that? Do you want me to talk more about like technical stuff like protocol buffers and how to open files and stuff like that? Maybe gRPC? I've been told that maybe I should do an episode about Grafana or some other lockers or libraries to do monitoring. I really don't know what you want me to do. So please let me know. You can leave your comments down here. You can send them to form.justforfunc.com, or you can find me on Twitter as Francesc. As always, please subscribe, tell all of your friends that you love this episode, and see you all in 2 weeks.